Okay, now we're going to graph y equals negative 3 to the power of x. But before we do the negative, I'm actually just going to graph y equals 3 to the power of x. And it's going to look like a Superman run, very close, very similar to y equals 2 to the power of x. But I'll just draw a very simple number line here, and I'll breeze through the numbers, but that way at least we have a reference to work with. So if I plug in negative 2 for x, I'm going to get 1 over 9 for y. If I plug in negative 1 for x, I'll get 1/3 for y. Plug in 0, I'm going to get 1. If I plug in 1, I'll get 3. Plug in 2, I'll get 9. So x is negative 2, y is 1 over 9. So that's just the point. Pretty close to 0 here, the 1 over 9. Negative 1 and 1/3. 0 and 1. 1 and 3. 2 and 9. So it's a pretty steep line. It goes up very quickly. Okay, so then over here I'll just draw a line pretty close to 0. Remember that it actually never touches 0, but it runs very, very close to it. It's an asymptote. That's what it's called, and it's at y equals 0. So we can even draw a dotted line here on the x-axis. Okay, maybe I should have picked a different color because you can barely see it, but that's okay. You know it's there, right? Okay, so now y equals negative 3 to the x, though. What's going to happen with this negative? That's just going to reflect every y value downward onto the x-axis. In this case down, but if we had anything down, it would go up. So for example, here we had 0 and 1, that will become 0 and negative 1. Here we had 1 and 3, become 1 and negative 3. And that was 9, so become negative 9. So it'll just look like this. It's kind of the opposite of a Superman run, really. Okay, and over here, just draw a straight line representing, showing that we get pretty close to 0. Not a big fan of the shape that I made here. Should be smoother, but that's okay, right? Hopefully everyone understands it well. And our red graph is y equals negative 3 to the power of x. Great. And this one, of course, was just y equals 3 to the x. That's it.